We're going to explore how to create a container design utilizing Design Strategy 2 found in Project 237. And with this, we're going to use Autodesk Fusion and some of the various tools it has to create an accurate container design. With this one, we're going to go ahead and start off by creating one piece of stock. So we're not going to create a new component as this becomes the component itself. So I'm going to create a new sketch. I'm going to choose the work plane, and we're going to utilize the same design that was shown in Design Strategy 1, which is also the example design found in the curriculum. So we're going to go with a 3" by 3" square. We're going to finish the sketch and extrude to a height of 2 inches. This will represent the stock that we're going to use to mill and create our container design. I'm going to go ahead and create a new sketch on the top of our container. We're going to create an offset from the outside edge of 0.125. For this case, since our profile is going to the outside, we're going to make this a negative 0.125, so that way it goes to the inside. And I'll select OK. With that, we'll finish the sketch, and I'm going to extrude. And the height of this profile is going to go to a base height of 1 inch. So, and in this case, a negative 1 inch to have us cut down into the container. This is going to represent the outside of the bottom portion of our container. I'm going to create a new sketch. Click on the top face. Very similar as we did for Design Strategy number 1, we'll create a series of arcs along the outside edge, and we'll apply the appropriate constraints in order to create the design that's shown in the example for the project in the Computer Integrated Manufacturing curriculum. Horizontal vertical constraints for the center points to the origin for each arc. Might have to look for those. All arcs are going to be equal to each other, applying equal constraints to each one of the arcs. And apply some dimensions. So from the corner to one of the points on the arcs, we're going to make that 0.5. We will repeat that process for each arc. Just one dimension from each corner. And apply our arc radius of 1.5. We're going to then finish the sketch. I will extrude, selecting the insides of those arcs, and we'll cut down to the top of the clamping boss in order to create the outside edges of our profile. So this starts to look pretty familiar. I'm going to go ahead and create a new sketch on the top face. We'll offset the outside profile that we just created by 0.25 to create the pocket. While we're here, we're going to create 3 arcs connecting to the larger arcs on the inside. So in the previous video, and you might see some automatic tangent constraints be applied, we will need to delete those later, so in order to make this work. So sometimes as you're drawing, Fusion thinks that it's helping you out by adding in some constraints. In this case, it doesn't really help us out so much. It kind of locks down some of the sketch. So I'm going to right click on the glyph for the constraint and select delete. All of these arcs are going to be equal to each other as well. The dimension for these arcs will be 0.375 divided by 2. And in order to constrain the geometry, we need to apply some tangency between the arcs and the larger arcs on the outside. So I'll do that for each side. Large arc that it connects to. And you'll see as we do that, we start to constrain the geometry. I'm going to go ahead and finish the sketch. We're going to extrude and select that inside pocket. Again, we are going to take a look at how much of a floor thickness we want. We want to go to the top of the boss, but we want to add 0.25 to it, so that way we have a little bit of a floor thickness in there for our container. And I'll select OK. I'm going to create a sketch again on the top face. We're going to offset this inside profile by a value of 0.25, so that way it'll go out to the outside curves on the outside edges of our container. I can finish the sketch, extrude, select the outside portions, the corners, and then select the top of the clamping boss to cut those down to get the outside of the container to the size and shape that we want. One more sketch, choosing the top, offsetting the inside profile to the outside by 0.125, finishing the sketch and extruding the outside edge down by 0.25. So that'll give the lip edge for the container, and this completes the bottom portion. Where this becomes really easy when doing design strategy 2, not that it's hard either with design strategy 1 or 2, but what we're going to end up doing is we're going to create a new sketch down on the bottom, and with that what we can do is I'm going to actually turn my sketch up so that way I can get the geometry from the bottom, and I'm going to go to create, project, and select the project tool. I'm going to choose the outside face, that way it gets the outside edge. I'll click on the inside, here, and here. So that way all of this, if I rotate to the bottom, you're going to see there are the lines. The outside geometry gets projected onto the sketch plane. I'll select OK. And from here, while I've got this active, I'm going to go ahead and choose the offset tool, select this middle curve, and go to the outside edge and add a 0.002 offset to the outside. So that way it goes to the outside edge. I'll select OK. From here I can finish the sketch, and what I can start to look at is now I want to leave a 1/4 inch clamping base. So in this scenario our lid height should be a negative 0.75, so that'll cut in to leave a 1/4 inch clamping base there. We want a little bit of material. So again, we've selected the outside edge. I'll select OK. That gives us the outside portion. And now, in order to get that sketch back, I can go over to my browser, expand the sketches, and turn on Sketch 7. I'm going to extrude one more time, selecting not only the inside pocket and this pocket as well on the outer edge, but I have to zoom in, and there's a small sliver that's going to represent our tolerance, that 0.002. So I want to zoom in really close and make sure I grab that. I'm going to go ahead and cut into that top lid, and our dimensions that we had for that were going to be a negative 0.3125 as per our dimension drawings for the example. Select OK. I can hide the sketch, and now you can see the lid design that's on the bottom for this container. So here we've modeled the top and the bottom all in one piece, and leaving a 1/4 inch clamping boss for our vise to be able to hold the material in and be able to flip it over and mill out the lid. So now the question is how do we get this portion to be able to fit together to check for interference and to see if this lid and bottom are going to, fit together well. So here's a little technique that I use, is that right now we don't have any components, but we have one body. So one body, and when I select it from the browser, this all highlights. So I'm going to leave this expanded. I'm going to go up here to modify, and I'm going to choose split body. It says select the bodies to split. I'm going to select the entire one, and then it asks for a splitting tool. So I'm going to select this option, and I'm going to choose this face on the bottom of that clamping boss. And I'm going to select OK. So now here's what happens. If I look at my bodies folder, now I have body 1, which you can see is split that in half, and I have body 2, which is the lid of the container. So what I'm going to do is on body 1, I'm going to right click on it and I'm going to say create components from bodies, and that becomes component 1, which I'm going to go ahead and name as container bottom. Body 2, I'm going to create a component from the body, and the component 2 now becomes container top. So now that they are components, now I can move and bring the top of the lid up here and try to fit it together. And if you want to, you can always activate the container bottom, create a sketch. We can always capture the position, project the outside edges of the clamping boss, and extrude. This is going to be a negative 0.25 to get rid of that bottom portion, just to see what it looks like. And then I can always activate the top level assembly. Same thing as what we kind of did in strategy 1. I can joint, select the outside radius there or any other corresponding point. I'll pick it here on this portion. Our lid is going to now fit together on to the top portion. Might need to check my second selection once more. So there we go. There we are. So there is the lid as it fits together. I can select OK. There's my container design. If I go to the inspect panel, choose interference, I'm just going to select the 2 components, click compute. No interferences are detected. I can check to see if there are coincident faces that touch, and we do. We have the same thing as what we had in design strategy 1. Those 2 faces don't interfere with each other, but they do touch, and so that's what we're showing in this particular case. I can also run the section analysis tool to be able to see what I have going on with the, and choose the work plane. Maybe rotate this around 180 degrees. Here is our container. If I look at it from the front, I can see that I do have a little bit of clearance there between the components. That allows the lid to be able to fit onto the lip. If I turn my section analysis off, this finishes the design. If we wish to machine this, stepping back the timeline to the point before you split the bodies would help. So I can always roll the timeline back to where it was, and then I can generate my toolpath and CAM strategy in the manufacturer workspace. So this completes creating a container design using design strategy number 2 and using some of the tools to make sure that we have an accurate design that fits well and that it's going to work within the constraints of the project.